All right, in example 5, we're asked to determine if each of the systems of equations has no solution, one solution, or infinitely many solutions, and if it has one solution, to find the solution. With part A, we don't even need to graph that, and if you need explanation for this, please just contact your instructor and ask. But anytime you have two equations where one is a multiple of the other, that represents the same line. So if you look at 3x plus 5y equals 12, and 9x plus 15y equals 36. If we multiply this first equation by 3, we get 9x plus 15y equals 36. So those equations represent the same line. And that's the point of showing you part A, is just to show you that when that's the case, you don't need to graph. You know it's the same line. All right, now moving on to part B. With part B, we have x plus y equals 4 and 2x plus 3y equals 6. So we'll go ahead and make our little charts here. X and y, we need at least 3 points. If we start with x equals 0, we know y equals 4. Now if y equals 0, x equals 4. So we only need one more point. Let's go with x equals 1. So 1 plus y equals 4. Y equals 3. So at x equals 1, we have y equals 3. So we'll just go ahead and plot our points. Let's go ahead and label our axes. We'll use a scale of 1. So 0, 4, we know that's 1 point. 4, 0, we know that's the other point. And then 1, 3. And those do line up. So we'll go ahead and graph that on our coordinate system. Now with our second equation, 2x plus 3y equals 6, we'll go ahead and we'll try to use the same 3 points, or the same 3 x coordinates. X, y, when x equals 0, 3y equals 6, so y equals 2. Divide both sides by 3. 6 divided by 3 is 2. When y equals 0, we have 2x equals 6. 6 divided by 2 is 3, so 3, 0 is another point. And we'll go ahead and use 1 here as well. So 2 times 1 plus 3y equals 6. Subtract 2 from both sides. 3y equals 4. Y equals 4/3. So 1 4/3. So we'll go ahead and plot those points. 0, 2, 3, 0, and 1 4/3. And it looks like these two lines are intersecting at the point 1, 2, 3, 4, 5, 6, negative 2. So our solution to this system of equations is 6, negative 2. All right, now on to part C. Again, this was part B. So now on to part C. And we have 3x plus 5y equals 8, and 6x plus 10y equals 24. And in case I didn't mention on part A, again, when one equation is a multiple of the other, it's the same line. So there are infinitely many solutions because they just overlap one another. Now with this problem, we have 3x plus 5y equals 8 and 6x plus 10y equals 24. I'm going to go ahead and simplify this second equation by dividing by 2. And that's going to give us 3x plus 5y equals 12. Now what you should notice right off the bat is we have the same thing on the left side, but different things on the right side. And what that tells me is that there's not going to be a solution. We have parallel lines. When you have the same thing on the left, something different on the right, or vice versa, depending on where the variables are. But definitely when you have variable terms on the left, numerical values on the right, and the variable values are the same, they have the same coefficients, and the numerical value, the constant on the right, is different, those are parallel lines. But we'll go ahead and work this problem out. Let's go ahead and plot some points. We've got xy when x equals 1, let's say. Then we have 3 times 1 plus 5y equals 8. That gives me 5y equals 5, so y equals 1. When x equals, let's say y equals 0. So when y equals 0, we have 3x equals 8, so y equals 8/3, or 2 2/3. And then we'll go ahead and use x equals 0. And yes, I know I didn't go in order. It doesn't matter as long as we plot the 3 points that are there. So then I have when x equals 0, 3 times 0 plus 5y equals 8. So y equals 8/5, or 1 3/5. So we have 1, 1, which I'll just plot right here. We have 8/3 0, so 2 2/3, so 1, 2 2/3 0. And 0, 8/5, or 1 3/5, so 1 3/5. And I'll go ahead and plot this line before we go to the next one. Now, with 3x plus 5y equals 12, or 6x plus 10y equals 24, they're the same thing. I just divided both sides by 2. Again, we'll go ahead and plot our points x, y. When y equals 0, we have 3x equals 12, so that means x equals 4 when we divide both sides by 4. So let's go ahead and plot that point. 1, 2, 3, 4, 0. When y equals, or when x equals 0, we have 5y equals 12. So y equals 12/5, or 2 2/5. So 0 and 1, 2 2/5. And then we'll go ahead and go with, let's say x equals 3. So 3 times 3 plus 5y equals 12. That gives me 9 plus 5y equals 12. 5y equals 3. So y equals 3/5. So at 3, it's 3/5. So 1, 2, 3, and 3/5. Now, as long as I draw this correctly, it's going to verify what I already stated in the beginning, and that's that this actually has no solution, because these lines are parallel. They will actually never intersect. So for part C, the answer is no solution. The lines are parallel.